Our next talk is on security guardrails at scale in Azure. Before we kick off, I'd like to thank our sponsors, especially Uptycs. Uptycs helps you quickly identify and eliminate security observability gaps. Whether your challenge is related to cloud workload protection, cloud security posture management, XDR, or all of the above, Uptycs has you covered. Learn more about uptycs.com, uptycs.com. Please welcome Kinnaird.
Thanks to everyone for joining. I'd like to say thank you to Forward CloudSec for having me out today. It's been a real privilege to be at this conference and hanging out with all these inspiring individuals and experts. So I'm really excited to share this project with everybody. We're going to talk about our approach to security guardrails in cloud and in Azure, how we're building security guardrails into our Azure environment to eliminate entire classes of bugs in cloud, and how you can do the same. So my name's Kinnaird McQuaid, and I'm a lead security engineer at Salesforce. I'm part of the Red Scar team under Salesforce Security Assurance. My part of the team has a lot of implementation experience, especially in public cloud. So what we do is, having a big picture view of the systemic issues in our environment, we take our knowledge and experience, embed with teams, and then focus on areas of strategic importance that will eliminate classes of bugs. I'm a hacker by trade, but I love building things, as you'll see here, and automating anything security related, and I love dogs. So today we'll talk about what preventative guardrails are in cloud and why they're so important. For this part, I'm going to stay a little cloud provider agnostic because I think these points are pretty universal. We'll talk about the different types of guardrails, how they work in Azure, its limitations, and how we put Azure policies on steroids to help developers innovate quickly. We'll talk about how Guardrails for Azure solves this problem and makes it easy for other organizations to roll out guardrails. We'll do a walkthrough, and we'll outline future work and how you can establish your own path to mature security guardrails in cloud. So why do we focus on guardrails? It is an overused term at this point, but it really gets at the heart of what we're striving to do, and that's to help developers innovate and get feedback. And by the way, when I say developers, I do mean security engineers, infrastructure engineers, DevOps, operations, anybody who has to build stuff in cloud, right? So it's hard enough to deliver product when management is breathing down your neck and you have tight deadlines, and then security comes out of the blue and says, hey, you forgot to lock down this damn S3 bucket or storage account or encrypt X, and you left that project months ago. And then you ask yourself, why did security not tell me then? Why is it that hard? And it is hard. It's hard to put those things in place. And while cloud isn't new, it's new-ish to a lot of organizations and to a lot of individuals. In my observation, it's been only in the last few years that the industry has settled on the tool category of CSPM, or Cloud Security Posture Management, and there's a race to add as many rules as possible between those vendors. Vendors for Windows security software, as an example, they've been doing that for decades, right? They've had more time for it to marinate. But in cloud providers are catching up, and I think that, and I can't confirm, but I think that they're probably tired of hearing about open S3 buckets and compromised container services. But the customers are still catching up, right? The customers still have to figure out our area of responsibility to keep our developers safe, which ends up keeping our customers safe. And that's where security guardrails comes in. So at Salesforce, we have a whole program dedicated to rolling out security guardrails. So here are some of the key points of our philosophy. A security guardrail is a mechanism that prevents a security risk from being introduced in the first place. That means no tracking down of a developer after the fact so they can fix it later. That means simple, easy to explain controls. It means it needs to be risk-driven. In my estimation, developers are artists. They care about their application, but they also want to understand why it's important to fix something, why they have to drop what they're doing to fix a bug, why it's important to follow a best practice. And that means it has to be a good customer experience. It needs to be near instant feedback. And ultimately, that's what is going to keep them and our customers safe. And here's the last key point of our philosophy: autonomous onboarding. we believe that the best security controls are the ones that developers get for free. So the controls should be directly embedded into their tools or their infrastructure and their workflow. So we want to help developers from introducing risks. So let's talk about some of the example risks that we want to prevent in Azure, and then we'll talk about the Azure policies. So we can have these guardrails at the cloud provider level for the Azure API and in the Azure Kubernetes service. We enforce our encryption requirements. We prevent things from getting exposed to the internet on the network level. We prevent excessive privileges, stop resource exposure, prevent storage accounts from being exposed to the public, et cetera. Now, we have two different strategies to prevent against those risks, generally speaking. So there are two different types of infrastructure guardrails, like provider-enforced guardrails and customer-enforced guardrails, generally speaking. So, these guardrails will help you prevent from deploying the insecure infrastructure in the first place so that developers can spend less time dealing with the security bugs, focus on building things, get immediate feedback, eliminate security debt, decrease bottleneck and security reviews, right? And the provider-enforced mechanisms, you guys might be familiar. I know there are a lot of AWS folks in the crowd, and you guys will be more familiar with AWS service control policies, or there's also Azure policies, which we'll cover later. And these provider-enforced guardrails are enforced at the API level, so if you're doing something insecure, they're going to block the API call. But this allows for simpler policies only and is dependent on what the cloud provider allows you to do. So we can't do a bunch of fancy conditions and logic, and that's fine because we have another strategy for the more complex ones. So with customer-enforced infrastructure guardrails, it is what it sounds like. We run the tool that enforces the security control. We do this by running a security tool in our CI/CD pipeline, et cetera, or maybe there's auto remediation, right? So with things like OPA and checkoff, those are more expressive than the provider-enforced mechanism because it leverages programming languages instead of like JSON config files. So here we'll cover a provider-enforced guardrail called Azure Policies. And it's a great example of the guardrails work that we do. So in case you aren't familiar with Azure Policies, I'll do a short primer. So in Azure, they give us a bunch of these security policies already. It's built in. So this screenshot shows the policy definitions in the portal. There are 476 policies already defined, last time I checked, and 29 policy initiatives. And these built-in policies are created by Microsoft and used for common security and governance needs. And it's not surprising to me that they went out and built something this robust. After all, they're the inventors of like the group policy objects. And so they give it to us baked in. AWS doesn't have that many, and they don't give us that many SCPs to choose from. We can leverage this from the start in Azure and get ahead of the game. And the truth is, as our North Star, the count of all these security-related violations in Azure can be precisely 0. We can have hundreds of those security guardrails for our other security controls, given all the ones that are built in for us. And we can select them a la carte, like encryption, least privilege, network security, logging, et cetera. So let's talk about how Azure lets us prevent insecure configurations within Azure Policy. Here I'm assigning an Azure built-in policy to my Azure subscription, like an AWS account, to prevent public access to storage accounts. When this policy is applied, no user is allowed to make Azure Blob Storage available to the internet. The second red box shows that it has a deny effect. And by the way, if you think that it's possible that you might break somebody, you want to set it to audit mode first, and then maybe you grant an exception for everybody who's in violation, and then you roll out the deny. And then that way you've stopped the bleeding, and then you can then focus on everybody you just granted a temporary exception to. So, and then in the third red box, that's the message that we give to the user, saying that they're doing something wrong and telling them why and giving them that instant feedback. So this policy reduces the risk of resource exposure in cloud. And it's just one Azure policy out of the 400 plus. And here's what it looks like from the developer perspective if they're clicking around in the portal. So here I tried to deploy a public storage account that had a setting that would allow public access. It didn't even share anything with the public, but in the future it could have. But we set the Azure policy that would block it. So in the Azure portal, after I tried to create it, it showed that the deployment failed. And then it told me the exact resource that it's forbidden, and then it told me I can click up top for more details. And then when I do that, it gives me some clear user feedback. In this example, it says that the resource was disallowed by policy. And not only do we say that it's blocked, we can give it a custom message. In this example, I said, hey mate, you can't be creating public storage accounts. Now in real life, we can give a more descriptive message, maybe refer to company policy or an exact ID, which can be really useful. And this stuff makes life much easier for the developer. Not only that, you can tell them why something is insecure. And hopefully that means that they are able to fix it without pinging you on Slack first and waiting for a response. So now you've heard that Azure Policies is pretty damn powerful. So what's the problem? Well, remember I said there are 400 plus policies. That's a lot. And deciding which one of the 400 built-in policies that you want to enforce and which stages to roll them out in can be really, really intimidating. And you start to ask yourself some questions. Are you going to dedicate headcount to rolling this out? How many people are you going to dedicate to it? Who's able to do it? Who has the background for it? Are you going to do it in automation? How long will it take? Everyone already has their own projects to attend to. How are you going to make time to do this when we didn't even know that this would be part of our Azure strategy from the start? And I've heard this from other Azure customers as well. And the truth is those are very valid questions, and we should make it easier, even as the customer. So here's the Microsoft recommended policy as code workflow looks like and how it's structured for managing Azure policies. If you wanted to assign a policy to just one subscription or management group, similar to an AWS OU, that means that you'd have 5 files per folder at minimum and a subfolder for each policy. So that means if we wanted to enable just 100 security guardrails, we'd have 100 subfolders and 500 JSON files that we'd have to manage. That's less preferable for some. It's a lot of JSON, it's a lot of clicks, and that probably means that it's going to be Bob's job and nobody else's, so have fun, Bob. Now, I've always been passionate about automating my way out of the problem, and that's a huge part of our team's mission, and to make security easier, usable security only, right? And I knew that it was difficult and tedious to manage this using the existing methods, despite how powerful and useful it was. And we wanted to get all of the benefits, not just a few. So I wondered, how can I automate my way out of the problem? Maybe I can find some Terraform modules that would do it for me. But there weren't any existing solutions that would allow us to roll it out as rapidly as we wanted and needed, and gave us the same coverage and lowered the bar of expertise required to roll this out. And so I started building something. And once we came up with this, I realized we had a pretty novel approach. And Salesforce loves open sourcing our tools. And I realized we should open source it because it would help a lot of people. So our goals going into this were to lower the barrier to entry, right? Like I said, you shouldn't have to be an expert in this to benefit from these lovely security controls from Microsoft. And the rollout should be easier. We want you to move from audit mode to deny mode very quickly. And you should be able to avoid breaking anybody. And you should be able to, and by that I mean low friction policies. You should be able to roll those out within minutes. And you should be able to easily roll back the ones that you don't want. So we made the process super easy. Step 1 is that you log into Azure. And then step 2, you edit the parameters.yaml file. So some of these Azure policies have parameters like which algorithm should be allowed in Azure Key Vault, or maybe which Kubernetes namespaces should be the only ones to allowed to run containers as root, or something like that. That's where you specify your special unicorns. So in step 3, you edit the exclusions.yaml file. That allows you to use name matching patterns to select or cherry pick specific policies And then step 4, you generate the Terraform. So you don't have to edit the actual Terraform. We generate the Terraform code based on the criteria above and which command line arguments you select. And then step 5, you apply the Terraform. So you might be wondering, what does this exclusions file look like? Well, remember I said it allows you to use name matching patterns to cherry pick or exclude policies. So in this first example, match only keywords, that allows you to specify keywords to match the policies that you want to use. So when we say match only keywords equals SQL, that means we only want to create policies related to the Azure SQL service. And in the second example, you can exclude keywords. So let's say that you haven't decided whether you want to force the usage of virtual network service endpoints or private link. No worries. You can specify those under exclude keywords, and the Terraform won't include those policies. And you can also exclude specific policies. So there are a few policies that, this is part of why you can't just select all for the 400 policies and just apply them, because it'll just make your environment go crazy. So there are a few policies that force you to only create resources in certain Azure data centers. And those are useful, but maybe we don't want to enforce those yet. And so you can exclude those here. There's also a parameters file, so you generate that file using the create parameters file command, and then you can pump in the parameters that you want. So in here, let's say in that first example, it says that the required days to retain a Key Vault resource log. So the default value is 365 days. If you want it to be something other than that, then you specify the different value here. And then when you generate the Terraform will reflect those parameters. So you don't need to edit the infrastructure, the actual infrastructure as code. You just need to edit a YAML file. And cloud engineers we're all just senior YAML engineers at this point, right? What's one more? So here's what the generated Terraform code looks like. It's a snippet, but this is the human readable part. You'll notice some crazy IDs there. Azure forces you to use these unique IDs, so you can't specify the names. And that's complicated to read, so we made the human readable name in the policy, of the policy in the comments on the right. So let's talk best practices for using cloud guardrails. So first of all, don't edit the Terraform manually. Instead, edit the parameters file to specify the values, and edit the exclusions.yaml file to cherry pick policies or exclude policies based on naming patterns. And there are also other command line options to allow you to query the data about all the policies in case you have questions, but it's easy to just generate the parameters file or generate the exclusions file and then just edit it and then generate the Terraform. And you can also, instead of editing the Terraform, change up your command line arguments. And of course, with any infrastructure as code, you'll want to manage this via version control, so store it in Git, and deploy it via CI/CD pipelines. And I also advise people to look into using Terraform to manage exceptions to those policies. So Jesse Loudon wrote a Terraform exceptions module that you can use to do this, and it's available at this link. So don't worry, we will share these slides after this talk if you want to grab the link, and it's in the GitHub README. And we have policies across all of these different categories: AppSec, auth, compute, stored, et cetera. And for encryption, there are actually 69 different policies, right? That's a lot. We eliminate a lot of bugs, not even just storage buckets or unencrypted disks. And it's not just one type of missing encryption. And as a result of this work, we have some really happy customers. I've anonymized the names, but some of them one said, thanks to guardrails, not only were we able to move quickly with a baseline set, but we were able to apply them at different points. So now when future orgs are onboarded to Azure, they simply inherit many of those policies by default. It took them 10 minutes to apply it, and they said having the guardrails in an easy-to-consume format was a lifesaver. And this is the stuff that fires me up and why I love what I do. We make it easy for developers to consume security. It's hard to get it right, but when you do, it feels good. So to recap, we made it a really easy process to apply those security guardrails. You log into Azure, you edit the YAML files, you generate the Terraform, and you apply the Terraform. Now, if there are only 2 things you can take away from this talk, the first is you should check out the tool. And the second one is to remember that the best security controls are the ones that developers get for free. Now, I have to very quickly make an obligatory recruiting plug. One of the things that I love about working at Salesforce is that management is committed to automation, including automation security activities. And certain challenges can only be addressed through certain careful security engineering, and our leadership does understand that. So if you're interested in working in Salesforce security, we're hiring and looking for those who have heavy threat modeling experience and secure architecture design, hands-on experience. We have a lot of other open positions too. We're also looking for Ali Cloud engineers, network security engineers, and cryptography engineers. So if any of this sounds interesting to you, feel free to message me on Twitter or the Cloud Security Slack. So, thanks so much for having me. It's been fun.
Thanks, Kinnaird. So a couple questions. How did you choose in the end which, there were out of, I think, 400 policies you identified, about 200 that you ended up running. How did you choose which 200?
I followed the process that I outlined and just, I selected them based on what made sense and had to have talks with different security control owners about which categories we wanted to select.
And so, it's you sort of drove the process of applying the technical controls, but choosing how it would work lived with sort of people in your audit organization as well? Or?
Yeah, exactly. So for example, if the network security control owner said, we haven't decided on private link yet, like the example that I said, okay, no worries. We'll just exclude those according to the name matching pattern.
And so if that evolves in the future,
Yeah.
where, okay, now private link is required,
Yeah.
what's the process of updating and rolling out these new baselines to existing projects?
So what I would do is I would generate one that just matches that pattern, and then generate the Terraform for that, set it to audit mode, and then grant exceptions to everybody who's currently failing, and then switch it to deny. And then you can go track down the security debt.
You mentioned, that if these things end up being sort of hidden or hidden to project owners.
Yeah.
Do they, and yet they're visible in some way because it makes them usable.
Yeah.
Do they have any involvement in the deployment of these policies, or just when the project is deployed, it has these things in it?
The developers, they can request exceptions as well, in addition to these guardrails, you also have to publish your security expectations and your requirements, so that way you're able to point to something that says, this is why we have this enabled, right?
One more. So the main if this is fully run under CI/CD, the only things you end up committing are the cloud guardrails config file, and then I guess the Terraform state config file as well.
The Terraform file, yeah.
Okay.
Yeah.
Cool. Any other questions? All right. Thank you very much.
Yeah. Thanks.